Okay. Hi. In this video, I'll be showing you how to find the tangent vector, the normal component, and the tangential component of a given position vector. Let's start with the tangent vector. The tangent vector can be found using the following formula. The derivative of the position vector divided by the magnitude of the derivative of the position vector. Let me write that out. Now, I've included this information over here because, as we've learned, the velocity vector can be found by the derivative of the position vector. So, if you already know that the velocity vector is the derivative of the position vector, or if you're already given the velocity vector at a beginning of a problem, then it's easier to use this formula. However, in our case, the position vector will be given, so we'll have to start from scratch and take the derivative of the position vector before we find the tangent vector. Now, here's an example. Find the unit tangent vector of the following. The position vector is 5 times sine of t of the I component plus 9 times cosine t of the j component, and t equals pi over 4. Now, the first thing we have to do is take the derivative of the position vector. Now, the derivative of the position vector, which is the velocity vector, is 5 times cosine of t, and don't forget the i's and j's, minus 9 times sine of t. Now when t equals pi over 4, the velocity vector will be 5 times square root of 2 over 2, and don't forget the i's and j's, minus 9 times the square root of 2 over 2. Now we have to find the magnitude. The magnitude of the position vector, or the derivative of the position vector when t equals pi over 4, is as follows. Now remember that the magnitude is a square root of the I and j components squared. Now this would be 50 over 4 plus 162 over 4. Don't forget the square root, which would be 212 over 4. However, this could be simplified. So now, the unit tangent vector is as follows. Now let's move on to the normal vector. The formulaic structure for the normal vector of a given position vector is similar to that of the tangent vector. The formula is as follows. The normal vector is the derivative of the tangent vector divided by the magnitude of the derivative of the tangent vector. However, as simple as it may seem, finding the normal vector this way is deceptively long. There is an easier way to find the normal vector, but first we need to learn how to find the normal and tangential component of a given position vector. The tangential component is given by this formula. The derivative of the velocity vector, or the magnitude of the velocity vector, or you can find it by multiplying the acceleration vector by the tangent vector, or you could find it by multiplying the velocity vector and the acceleration vector and dividing it by the magnitude of the velocity vector. Now, there are some situations where this will be more useful than this, and this will be more useful than this. But for this example, or for this demonstration, I choose to use this. Now, the normal component is given by this. The square root of the magnitude of the acceleration vector squared minus the tangential component squared. Now that we figured out how to find the tangential component and the normal component of a given position vector, let's find the normal vector of a given position vector. Now the easier way to find out the normal vector is given by this formula. One over the normal component times the difference of the acceleration vector minus the tangential component times the tangent vector. Now let's do an example. Recall our first example where the position vector was given by this. Now our task here is to find the normal vector when t equals pi over 4. Now, recall that we already found the tangent vector in our last example, and since we're using the same position vector, we could just write it out here. Now we need to find the tangential component and the normal component. The tangential component is given by this formula, as we've covered a minute ago. Now the velocity vector is the derivative of the position vector, so it can be written like this: 5 times the cosine of t, don't forget the i's and j's, minus 9 times the sine of t, j. And the acceleration vector is the derivative of the velocity vector, so we can write it like this: negative 5 times sine of t, I, minus 9 times the cosine of t, j. And we just need to take the magnitude of the velocity vector, which can be written like this. Now when t equals pi over 4, the tangential component is 5 times square root of 2 over 2 minus 9 times square root of 2 over 2 times negative 5 times square root of 2 over 2 minus 9 times square root of 2 over 2 all over the square root of 25 times 2 over 4 because we squared it, plus 81 times the same, 2 over 4. You could cancel these out, so the denominator is 2. And simplified, the tangential component would look like this.